Hi, Steve from Steve's Makerspace. In this video, we'll be looking at how to resize your canvas in p5.js and change pixel densities and have the image produced remain the same. This is a tricky problem and is necessary if you want to sell NFTs on fxhash. This video is part of a two-part presentation on how to sell on fxhash, though you don't need to be selling an NFT to learn something useful from this video. When people buy an NFT on fxhash, they might want to print and frame your art or display it on a big screen. A big piece takes a while to produce, but when they're checking out your iterations on fxhash, they don't like it if it's slow. They might give up on your project. So you need your art to produce quickly at a low resolution, but has to scale up to a larger resolution, and it has to look the same no matter the size. I'm going to start with showing you something that uses the scale function, but I have to warn you this is not what I'm recommending. I think it's good to know about it, but if you want to skip ahead to the solution I actually recommend, the video is indexed in the timeline. So this is my code to scale something quickly, and if I change this, you can see that it quickly changes. This one is for rectangles. I also have another one for squares that's a little bit easier, and you can see it scales very quickly. And I also have an example here that does the same thing, but it's a more complex example so that you can see that it actually remains the same even if it's complex, and you can scale it very quickly. What I'm doing with the scaling is I'm drawing to a buffer canvas and I'm making it really big, and then I'm scaling that down. I've got the scale function here in the draw loop, and you can see the image coming right after the scale. If you look in the P5 reference information for scale, they talk about rectangles and circles, scaling those, but this works for images as well, even including a buffer canvas. So if it works so well, why am I not recommending it? Well, I'm drawing at a large size and then scaling it down. When I draw at a large size, it takes more time. Whereas if I just drew it at a small size, let's say somebody's trying to do the iterations on their phone, it's going to take the same amount of time if I'm doing the scale, having it render on their phone versus on a large computer. So that's one thing, is just it's taking more time than it needs to take. But the more important problem is that you're limiting yourself in how big you can scale. Because if I'm scaling at 2000 wide, but somebody is minting your NFT and they actually want to print it at 4000 wide, they can't do it because you've limited the amount you can scale. So this easy scaling method doesn't really work. I'm not actually going to go through all of the scale code because I'm not recommending it. So you're welcome to check it out. I'm leaving links to this code in the video description. So now let's look at what I'm actually recommending. The main thing to remember is anything having to do with size has to be a percentage of the width or height, and anything having to do with the number of items cannot be a factor of the width and height. The code has to have the same number of calculations regardless of the canvas size. In order to talk about the issues with resizing, I'm going to be going through a code example, but I'm also going to be using a fxhash template that I put together. So I will give you this fxhash template, which this one has a very simple code. All it's doing is creating a circle, a random circle. It also has some grain in here. The grain is not my own. It's a grain shader, and this is by Dave Pagurek, and I got this by reading Gorilla Sun's article about grain. So you can check out Gorilla Sun's article. I'll leave a link to that in the video description, but this isn't about grain. So this is the example I want to go over with you. It has a number of problems with it to start with. So the first thing I'm doing in setup is setting a seed for fxrand. This is to use for random number generation. You cannot use just regular p5 random for random number generation using an fxhash project. Now you could replace all of your random numbers with fxrand, but the thing to do is to call this a seed, and then down here we're going to do random seed, seed, and noise seed, seed, and that's going to put that fxrand number into here so that after that, all of your regular p5 random functions will work properly. So the only thing I'm doing in setup is that I've got a counter here, and then I'm doing restart function, and then the restart function is where I'm doing all of my work. I've got a pixel density using PD variable. That starts off at 1, but it could change. And then I'm creating my canvas. Now right now I'm creating my canvas using hard-keyed numbers. This is something a lot of people do when they're first starting off, is using a canvas that uses hard numbers based on whatever screen they happen to be using. The problem with this, of course, is that people are going to be rendering on all sorts of different sized canvases on their computer, on their phone, and so you can't really do this. So let's comment that out, and I'm going to comment all of this in. For our canvas, I'm going to create a canvas using the window width and the window height, but instead of window width, window height, in this case I'm trying to create a 3x4 aspect ratio canvas. So I'm taking the window width and then dividing the window width by 3, multiplying by 4 in order to get a 3x4. But when I do that, the height here might be shorter than the height of the canvas if I do it that way. So I've got an if statement here. If the height is greater than the window height, then we need to resize the canvas. And now we're going to resize the canvas taking the window height, divide by 4, multiply by 3. That's for the width. So that is going to resize the canvas so that it now fits in the available space, but still has an aspect ratio of 3x4. Next, I am creating a variable called maxCanv, and this is going to be the minimum of the window width and the window height. I'm going to be using this variable and multiplying things by this variable. I'll get to that in a minute. Now, the reason, if I return up here for a minute, the reason I've got main canvas equals create canvas rather than just have create canvas is because this variable main canvas is going to be used with the grain shader. So that's not really important to the resizing. There is also this here has to do with the grain shader, a grain buffer and a grain shader variable. That's Mr. Dave Pagurik's code. The other thing about the grain, if we just look at a little bit of this grain code, this is where you would change the grain amount. So if I put this to 0.2, then we're going to see a lot more grain. Whereas if I only had this at 0.02, I would see almost no grain. So I would keep this around 0.08 or 0.1. So we do a background. That is pretty standard. I'm going to do a stroke weight of 5. We'll change that in a minute, but let's leave it for now. And then I'm going to do I equals 0, I divided by width times 0.1, I plus plus, because I'm going to draw a whole bunch of circles. And let's say I think, oh, well, I want to draw a different number of circles depending on the size of my canvas. If my canvas is larger, I'll draw more circles. If my canvas is smaller, I'll draw less circles. Well, the problem with that is if you're drawing more circles or less circles, then your picture is different. And it can't be different if you're doing fxhash. I got rid of the big circle, but if I make this smaller now, you'll watch the dots. You'll see them disappearing. So they look different. Now they're reappearing. So we don't want the dots to disappear and reappear at different sizes. So instead, we're going to make the same number of dots. I'm just going to hard key that. Let's change this, get rid of that, bring this one in. So now we're just going to do 90 dots no matter the size of the canvas. So let's run that again. Now if I resize, you see the dots do not disappear. But now the dots are getting really close together. Look at that. Now they're far apart because the dots are the same size, no matter what size the canvas is. We want the dots to change size depending on the size of the canvas. So right now I've got the dots at size 30. If we comment this out and then comment this in, I'm using that max can, remember that? And I'm multiplying by 0.05. So if I do this, you'll see as I make it smaller, the dots are getting smaller, and as I do this, the dots get larger. So now it's starting to look about the same, whether it's large or small. But there is another problem. If I've got it this size, notice that the stroke weight is not as noticeable because you see more of the inner part of the circle. But if I make it smaller, you can see that the stroke weight pretty much takes over the circle because it's still a stroke weight of 5. So you're seeing less inner part of the circle. So the stroke weight also has to be a factor of the width or the height. Now that might not be the case if your stroke weight is just 1. But if your stroke weight is something like 5, then you're going to need to make it a factor of the width or the height. So I'm using max can times 0.005. Now how am I getting that number? What I did was I said, okay, if I wanted 5 and my canvas is usually 900 wide or tall, let's do 5 divided by 900 in my calculator, and I get 0.005555, and I just rounded that to 0.005. So that's how you do that. You make it look nice on your screen, and then you come up with whatever the percentage is to get the same result. I should pause here and recommend that you not do all of your code and then come back and try and convert all your code. You should be doing this as you're building your project. Use the max can for something like it so that you're not having to redo everything later, because that's a real pain in the butt. Now let me pause, let me stop and talk about the max can variable that I've got here. I'm using the minimum of the window width and window height, putting that into this max can. You could do the maximum of your window width and window height, or you could just use the width or the height, one or the other. If your aspect ratio is going to be the same, you're not going to change your aspect ratio for this project. But let's say you have an aspect ratio that's 3:4, or you want to also have 4:3, portrait mode, landscape mode. Then in that case, you're going to have to do something like this, where you're taking either the minimum or the maximum, or you could also do some sort of average of the window width and the window height. Because otherwise, if you do aspect ratio, a landscape, and portrait, and if you do the sizes of things like circles based on the width, well, when you do the 3:4, then the circles are going to be small, whereas if you do the 4:3, your circles are going to be large. And you probably don't want the circles to be large or small depending on your aspect ratio. I've changed the stroke weight. Let's take a look at that. So here's the stroke weight using a percentage of the canvas, and we'll make it smaller. Let me get rid of this bit of code so it's a little more clear. So you can see that the circles look pretty much the same. The stroke weight is changing, and so they look about the same. So we've got our little circles working well. Now let's look at this load pixels section that I have. There's a few problems with load pixels and using the pixel array. I don't want to give a lesson on using the pixel array if you're not familiar with it. Dan Schiffman has an excellent video on how to use the pixel array. But the problem with the pixel array is it's using the width and the height for calculations, which means that if it's a smaller canvas, it's going to use a lower number of calculations. If it's a bigger canvas, it'll have a larger number of calculations. That means that anything done with the pixel array is going to change the look of things depending on the size of the canvas, which is a no-no. The other thing with the pixel array is that pixel density is going to affect the pixel array. I'm giving the user the ability to change the pixel density. So they can press 2, 3, 4, or 5 and get a pixel density of 2, 3, 4, or 5, and then it restarts and it re-renders using this new pixel density. So here I've got a glitch effect happening with pixel density 1. If I change this to pixel density 3, you see a couple of problems here. One is these circles are being added and the effect is only happening at the very top of the canvas. To fix the circle problem where it's shifting these circles around, I've got to change my shift calculation. So right now I'm trying to shift things 1 pixel up or 1 pixel down. If I comment this out and comment this in, notice this shift I've multiplied by pixel density. I can do 3, and we don't have that weird duplication of circles at the top. However, if I save this, open it up, and we take a closer look, we've got this glitch effect here, but if I go farther down, the glitch effect is not happening farther down. Going back to the code again, in order to get the glitch effect all the way down the canvas, I'm going to have to multiply the height times pixel density again. So let's get this, and now I can hit 3. Let's do a save, and we'll zoom in, and we've got the glitch effect at the top, and if we look at the bottom, the glitch effect is happening at the bottom as well. So I fixed that, but after I do this, remember I'm doing a lot of calculations. Let's say I want to draw a circle after I do all these calculations. So let me uncomment this. If I try to change the size of the canvas, you see the circle is moving all over the place because I've got more calculations before I get to the placement of that circle. So to fix that, I am going to reset the seed. So remember this counter that I talked about earlier? I've got that at 0 up here. Counter plus 9999, and then we'll redo this seed with seed plus counter. And so this is going to reset the seed. This is still not going to work. Let me show you. And the reason it's still not working is because I put the counter at 0 here in the setup, but I didn't put the counter at 0 in the restart. And when I change the size of the canvas, I'm going to restart. The counter can't already have a bunch of numbers in it. So we need to put the counter back to 0 here. So that's something to consider if you've got global variables or something in setup with a number that is going to change during the code. You need to have those variables reset in the restart section. So now I can change the size of this and that circle will stay where it's supposed to be. So the other thing I would say about the pixel array is that if you can, learn how to use shaders. I have not learned how to use shaders yet. It's on my list of things to do, but if you did use shaders, the shaders will change all the pixels at the exact same time. So it's really only doing one calculation, whereas the pixel array is doing a whole bunch of calculations. So we can see that easily by doing another circle after we apply the grain. And I'll uncomment this out so we get a new circle. So there's our circle, and let's change this. And you can see that the second circle is staying put. If the apply grain using the shader was doing multiple calculations depending on the size, then that circle would be moving around because I'm not resetting the noise before I draw that new circle. So let me go over the last bit of this code. And then we have fxpreview. The fxpreview is just necessary for FX projects for when your code is finished and you need to create the image or thumbnail that's going to appear on fxhash, or the actual token image. That's what the fxpreview is for. That's telling fxhash to capture the image at that moment. Here we've got our key typed, and I've got if key equals s, that's for saving, and then I've got the 2, 3, 4, 5, changing the PD and restarting. I've also got this function window resized. So anytime I'm resizing the window, this function gets called. I'm changing it back to pixel density 1 and restarting. That's all of the code. Now you might think, oh, I've got this cool fix using this counter, but this is kind of a last resort. Let me show you what happens if you try to use this in some other place, like in this for loop up here. We'll try to use it with the for loop for creating the circles. So we'll place it right here. It's going to be redoing the seed, adding 999 every time it goes through to make a little circle. Let's see what happens. And it did this. You don't have circles all over the place. You've got them very orderly. Well, I'll just change this 999. That must be the problem. Let's change it to 99. Okay, let's change it to 959. That's still pretty orderly. Let's change it to 953. No, that's not going to work. So you can't just use this trick willy-nilly. This has got to be a last resort trick for fixing problems with resizing. A few final things to say. I suggest implementing different densities early in the coding process and testing it as you go, both different densities and also different size canvases. Each time you put in an algorithm, try it out and make sure that it still works properly. The final thing I would say is I said don't use the scale, but you might consider trying to combine these two methods of using the scale and using this reproduction. I don't know. I don't think I'm going to do it, but you might consider it. I think that's everything I wanted to go over with you about resizing and pixel density. The rest of selling stuff on fxhash is more straightforward. This is the most complicated piece. So check out the other video on everything else about selling NFTs on fxhash. If you like this video, give it a like, consider subscribing to the channel, ring the bell for notifications. Comments are always welcome, especially if you're experienced and you have some ideas about what to do with resizing the canvas and different pixel densities. I would welcome your feedback. Thanks for watching. I will see you in the next one. Bye now. Steve's Makerspace.